While our next speaker is getting set up, I'll quickly introduce him. Our next speaker for the day is Piyush. Piyush, he's been a stalwart of the Pune community for a long time. He was the founder of Ugwe, a consulting company that focused on high performance and scalability. And Ugwe was recently acquired by Trusting Social. And Piyush now heads SRE for Trusting Social. So that's our next speaker. And I shall hand off as soon as we're set up.
Yeah. Audible? Perfect. So, how many of you are feeling cold? Yeah, cool. All right. I don't know why conferences just keep the AC so low. So, okay, I'm talking about TLS. Everybody here is aware of what TLS is. Who doesn't? Raise your hand. I'll go into that depth. This talk is more driven by you than by me. So if you say you don't know it, I'll explain it. Okay, everybody's good? All right. So this is what interesting. Like this is the phases that I went through when I was actually dealing with TLS. First I thought it was broken, then I fixed it, then it was broken again, I fixed it. And I think the conclusion is it will actually remain broken. I'll take you to the history of it now, why I reached this conclusion. Part one, every developer goes through this, the green lock, right? When we look at TLS, we care about that green single icon on the web browser where you say https google.com and you think that's TLS, right? That's how we start. Simple Go lang code here, listen and serve, 443, there's a cert, there's a key, we publish, we go to the browser, we find a certificate, and that's it. Please do not try to DDoS that link. Yeah. So I'm not going to spend time on that. So simple diagram, what it explains how it goes through is you have a HTTP server which talks to a C authority, you send a CSR, which is a certificate signing request. What you get back is a certificate, you display it, you get that icon, everyone's happy. Part two, we make this more interesting now, where we say is that now I have not just a browser, I need to talk about a server and a client which need to communicate with each other but using some sort of authentication. One of those methods could be TLS. Becomes slightly complicated, but still fairly easy to understand. Through the journey of this talk, I'll just take these code snippets. I'll keep adding few lines at a time to make the problem more complicated to address the next challenge. So this is not a HTTP server, this is a TCP server now, right? Now for TCP server, obviously the HTTP part won't work. What I do is I load a key pair, which is there's a cert, there's a key. I generate a small TLS config, which has a certificate in it. I start a TLS server, start accepting the connection, and then there's a handler. On the client side, there'll be something which is pretty similar. Do not try to DDoS that link as well. By the time the slides reach out, I'll omit them. So there's a TLS config again. Pay attention to something which is commented in there. We'll come back to this later. We make a connection request. Hello, we get the data. And this works. Now, this is what a typical flow would look like. There's a client. It's no longer a HTTP client. We're talking about a TCP client. You send in a request. You get a certificate. What you get back is you can authenticate and work with your communication. Fair and easy so far, right? All right, cool. Now, there's another thing which what we call as opportunistic TLS. The interesting thing about TLS is, so where does TLS fit? Like if I was to say in the OSI stack, how many of you think it's level 4? How many of you know what OSI stack is? Okay. So how many of you think it's level 7? Okay, make it faster. I'm running out of time. So, okay, level 7 is what do you think? Who says it's level 4? Okay, interestingly, both of you are right. So TLS is actually a protocol which can run on top of other protocols as well. So you can have SMTP, you can have FTP, you can have all these wrappers which are actually communicating over TLS. Now this is where we introduce something called opportunistic TLS. What this means is any regular connection can be upgraded to a TLS communication at any point of time. Very simple Go code to achieve this. Now, one of these things that we have always read while configuring our Gmail, right? Like all of us have done SMTP, POP, IMAP configurations, and we say start TLS, right? Anybody ever wondered what that is? Okay, so that's what start TLS is. Start TLS is take a regular connection of SMTP and bump it to a TLS connection. Now, I have a regular connection which says listener.accept. Now, based on a certain packet, every time I see start TLS, I will bump it up to a TLS connection. Ever wondered what HTTP 1.1 upgrade meant? Like, you must have read this, right? HTTP upgrade header. That's exactly what this is. So basically, you can upgrade yourself to a TLS connection over a regular communication itself. Advantages, well, your same port can actually serve now both TLS and non-TLS for backward compatibility, incompatibility. Your same port can be both secure and insecure for whatever reason you may want it at the same time. Part 4, TLS client auth handshake. Now, what does the exact handshake look like? This is important. You must have read this in books in college. I didn't. But if you did, how this works is a sender basically speaks with the recipient and says that, hey, I want to do something. I will not take an example of a standard HTTPS because that kind of plagues our mind to introduce a browser in it. So I'm taking an example of a secure email. Now, you open up a connection and you tell that these are the ciphers and the modes that are available to me. What the server does next is it hands out the security certificate and a key, which is validated by the client based on wherever this is coming from. You encrypt it and you send it back. This is a standard message. You can read it in textbooks. I'm not here to explain this, but this is good to understand a background of how this communication works, and there's a lot of handshake happening. Now, we keep saying this word certificates all the time. What exactly is a certificate? Certificate is basically just a claim of ownership that any party possesses. Now, if you go back to any of these diagrams, we keep introducing a CSR, right? It's a certificate signing request that we send to a certificate authority. And you know what a certificate authority is? Like Let's Encrypt or Komodo. The same thing that you pay $399 every year, that's a certificate authority, right? So when you send in a certificate authority or a request, what you get back is something which you can freely exchange, which is a derivative of your public key. That's a certificate. Simply put, what does a certificate look like? It's a begin, public keys, private key. You have all seen that, right? Now, internally, what the information it carries is something like this. You can DDoS that link. It's not mine. So I'm just trying to do an OpenSSL on wikipedia.com right now. Just a small single bash. Don't pay attention to that. Pay attention to this. This is the amount of information that a particular certificate carries every time you start a secure handshake connection. Now, there's a lot of information is there. Like there's a date of expiry. There is a bunch of other things which we'll come back to. We'll cover all of this. And there's a serial number in there. You can use that command on pretty much everything. Now, these are the private keys are supposed to be kept with you, like your parents have been lying with you all your life. So keep them safe, the keys. Client authentication. Another aspect of this communication, this whole protocol exchange that we're talking about of TLS is also when we start dealing with server-to-server communication. Now, taking a few minutes back, like when you talk about these microservices, right? Now, servers have to communicate with servers, and some of them are going to be public servers. How do you authenticate and validate that only a legitimate party is accessing your server? Standard ways that we have always discussed is API keys, etc. I mean, username, password, basic auth. One of those modes is client authentication, which is supported as a part of TLS itself. What that means is that if there is a server that has anybody ever seen this where a browser asks you for a certificate? You have. Your gray hair says you must have. So, yeah. Anybody else? Anybody from younger people? Okay, no. So, okay, no hair. Yeah, same story. So I have as well. So, yeah. So this is basically just I'm trying to access a server which has request for certificate enabled in it. You know, this is the part where it starts getting interesting because so far, whatever we have done, we always do. We need to look beyond what is there. And when I started working with this, I realized, okay, so TLS actually has a feature. Now, if you go back to the communication, here, right here, there's an optional feature where a server is going to ask a client for requesting the cert as well. So at this point, the client has to present its own certificate that it possesses, and that's where the validation happens. Now, this is another way of getting past your standard authentication mechanism. Now, I've used a browser because it's the most visual thing to represent. Like, I could not have done this on a server-side thing. Why is client auth needed? I don't know, you would. So, well, in case you do, you can use this. A lot of people say, but we use API keys, right? The difference here is that you can't usually always use API keys. Reasons. API key is passed through as a header, right? So if I'm actually sniffing your packet, I know what this API key is. So if that is compromised, game over, right? Now, you could say that, hey, I could invalidate a API key. That's correct. But sniffing a HTTPS or a TLS communication is worth nothing. They can sniff it, but it's all encrypted. Now, coming back to what a client certificate looks like, pretty much similar. The only difference is it does not have any server information with it. This is the server that I'm going to host myself at. Now, if you come back to the same code, all I have to do is, in my TLS config, I say tls.require and verify client cert. Now, the moment I do this, your flash is on, by the way. Yeah. Never mind. So you say that request and verify client cert. Now, the moment you do this, the server starts accepting every request that comes in. It says that, hey, you need to validate this. Now, okay, fair and simple. Let's move forward. Now you have all of these services, right? Have you ever wondered why there cannot be a HTTPS certificate for localhost? Anybody can guess? Answer? Well, it has to be unique, right? Yeah, that's the answer, I know. So I wrote it there. Because, well, so there was before this circular came out in 2012, there were 370,000 websites on the internet which actually used the word my mail. Now, there were certificates which were issued for it, right? Now, no, you can't really have a certificate for something which is not unique. Like if I land on a web browser and I go to my mail, which is my company's own thing, anybody could hijack it, DNS directed me to somewhere else and which also says my mail, right? How do you validate the authenticity of this thing? So certificates can only be for public infrastructure, public facing things. Now what that means is that if I'm dealing with internal IPs and search for exchange between internal servers, how do I do that? Now, this is where we introduce PKIs, public key infrastructures. What this means is that you need to set up your own CA. You must have read this, right, on internet, like how to set up your CA. This is the part how you do it. How many of you are aware of what a PKI is? Okay, so you can sleep for the next 5 minutes. I'll come back to you. So for the remaining of you, like this is what it looks like. So you have a server. Now you send a CSR request. There is a CA that you run by yourself, which actually generates a key cert, sends it to the server. The client does the exact same thing. Step 1, 2, 3, you send a CSR, you get a client cert, and these can happily communicate with each other, right? Now, because I'm using my own CA, now the server needs to change a little. Rest, everything remains the same. What I add is a client CA. Now, why is this a client CA on server side? Because I'm validating whether the certificate being submitted by a client is valid or not. And I create a cert pool out of it, fairly straightforward. I read the file of the root CA path, I append it to the cert pool, and I start serving this. On the client side, there'll be a similar change required. All I need to change is, on the client, I'll call it a root CA. Because a client needs to know the cert being provided by the server, is it valid or not? Now, when I say valid, is it authentic or not? Because cert is a validation of the possession of a private key that I have for which public key is being sent. So that validation is done by the CA server. Now, interesting thing is, while all of these certs are there, how do we revoke it? This is actually the biggest problem. And this is where it starts getting complicated. if I have issued a certificate once and a browser and you have a client has it, the client, there is no way that this can be validated whether it has been revoked or it hasn't been, right? Because the cert comes in, obviously it is valid. Like there's a certificate for it, the private key along with it. It's like saying, how do you invalidate a private key for a public key or the other way around? You can't, right? Like once it's there, it's there. There's no way to invalidate it anymore. So for this, there's a thing called CRL, Cert Revocation List. So cert revocation list is a small header that is actually hidden down there inside the certificate, which is a standard HTTP URL. So every time a cert has to be validated, there's a CRL list with it, which has list of all the serial numbers of the certs that were invalidated, so that the client or the consumer knows that this is no longer a valid certificate. Can anybody guess a problem with this thing? Anyway, this is what it looks like. So if you try to open up a CRL, this is what you get, and it has a list of all the certificates that were ever invalidated. So it has a huge list. So every CA is going to commission a list of revocation lists of certificates that are no longer supposed to be valid. A typical flow of information looks like that every time the server is going to hit this information, it's going to fetch the CRL server, get the list back, validate it whether it is valid or not. However, there's a massive problem here. The massive problem is this is over time of internet, right? So if I've invalidated something in 2005 and a request comes in 2020, it should still be invalid, right? So the list is only going to increase with time. Now what that results in is that currently the CRLs that are there on internet are actually millions and millions line long, because well, people don't stop stealing, so you keep invalidating their certs and it keeps getting appended. Now this list only has to grow on and on and on. And at every single client handshake, the cert has to be validated inside a million lookup. Like it could be a hash table lookup. You could say it's log n because it's just a serial number that you have to validate. But still, it's a million records and it has to be transferred every single time. Now, to solve this, they introduced a thing called OCSP. I forgot the full form of it, but you can Google it up, I'm sure. Now, OCSP, how it works is, alongside their CRL, there's also OCSP server. What it does is, the same serial number, you validate against a OCSP server and you say, is this certificate valid or not? Slightly different. So you don't fetch million lines. You're actually making an API call and say that, hey, is this valid or is it not valid? And the answer that you get is yes or no. However, there's a challenge. If you keep staring at this diagram, you'll understand there are multiple challenges here. Let's say there's a browser, right? Or let's say you are the browser, and you try to visit a website. What you get is a cert. The cert has an OCSP server to it. You contact the OCSP server. OCSP server is down. What do I do? Am I supposed to go forward? Am I not supposed to go forward? That is one challenge, right? Because I can't decide whether this cert I'm actually allowing someone for lack of communication, or is this, what am I supposed to do? This is a case that browsers can decide. And interestingly, this is actually not a part of any language as well. So if you may go to any language spec, no language is going to do this for you. So when you use a TLS server in Go, Java, Ruby, Python, anything, they can't do this for you, this validation. You have to do it yourself. Why? Because a language can decide for you whether or not it should stop the communication. And imagine how slow the communication would become if it had to make a request every single time. Every single request that you make on HTTPS, and while we are moving on HTTPS, everything, the whole internet would become slow. That is one challenge. Second, this OCSP server, what if I DDoS this as an attacker? It can't respond to the queries which this server is asking for. Again, the same problem. Pretty complicated and sophisticated, but you can't actually solve it. And obviously, there's a privacy compromise, right? Because then now the OCSP server can build a journal log of who's going in where. And if you remember the OCSP server, can that be HTTPS? No, right? Because who's going to validate the authenticity of OCSP server itself? So it's kind of a recursion, right? Now, if you hit that recursion, OCSP server has to be HTTP. If it has to be HTTP, it is no longer encrypted, which means that you can still sniff it. So we're back to the same problem where we started. And yes, this still goes on, and there's no solution for this. So soft fail is where browsers and every server says that in case I can't reach OCSP server, I'll take a hit, I'll allow the request. That is the default specification. And well, if you don't believe me, here's it for you. Firefox is the only guy who does this, by the way. If an OCSP server validation fails, it will tell you this. Chrome, on top of it, is, look at this. I visit a site where the certificate has been revoked, and here's your green lock, which actually says secure. Despite a certificate having failed and been revoked, you still see a green sign. So next time you're actually trusting your green lock, you might want to check the certificate in there. So, and that is how it works today as well. Hard fail. Hard fail is where you decide, okay, well, I'll take a hit. I'll say that every single time there is a request that comes onto my server, I'll make a call to the OCSP server and I'll fail it, which is fine. It's a choice that we make if we are running an internal communication. I come to the conclusion that everything is broken in this world, right? And fragile. So you can make your pick the way you want it. Part 7. Why do you want to revoke keys at all? Like, if there's so much problem in revoking keys, might as well not revoke it, right? Like, what's the need to revoke a key? No, I mean, this might look silly, like, but it's actually true. Now, this is where things like Let's Encrypt come in, right? Because they only issue you a very short-lived certificate. So next time you find yourself complaining, right? Why does Let's Encrypt gives me only a 60 days of certificate? That's exactly the reason why, because they can't decide what to do when the cert fails. And if you think, why should you revoke a cert? Just go download this tool on GitHub. Simple tool, go to any website, steal their certificate if they haven't actually fixed their heartbleed bug. So, best part, it's written in Node.js. So, beat that. Anyway, it points out that this tool could be illegal to use, so you don't want to use it everywhere, right? So, just be cautious. Right, so now, what do? We need to add a cert validator. Same server code. We add any verify peer certificate. By the way, if you realize, all of this is actually a part of standard Golang library, right? So these have been there. Wait, what just happened? Okay, so, yeah. Was it your flash again? No, okay, cool. So client CS, right? So you have verify peer certificate. So all of this is there. The provision is there, but you have to go and do this yourself. So next time you're actually happily doing a TLS communication and exchange in Golang library or any single language for that matter, by default, they will not do any such thing for you because they can't. So you write a simple cert validator function, which, okay. Anyway, so which accepts a cert and you can do whatever you want to do with it. Like you may want to do a validation of the cert, call an OCSP server. The choice is yours. The language can make this for you. Part 8 is at Trusting Social. We basically run a lot of services, and we run into this problem all the time. And what we did was we packed all of these goodness into a thing called CA Toolkit. It's a shameless, cheap copy of CFSSL by Cloudflare. But it's written on top of it. It does a lot more than that. So you can actually download this GitHub repo, check this out to see if this solves a problem for you. Parting note. Maybe security is just a feeling, right? It doesn't really exist for you. Yeah, who am I? I'm Piyush Verma. I do site reliability engineering at Trusting Social. That's my Twitter handle, and that's my team sitting at the back. They have done all of this. I'm just presenting this on their behalf. Yeah, cool. While I have 1.5 minutes, there's a lot of work which is actually going in a thing called certificate transparency. This is a project by Google. What they do is that every time, now this is for public facing certs, like when you go to Let's Encrypt, not something that you run inside your organization for your own PKI. Every single cert that is actually being issued, there is a public ledger for it which you can download and query against in real time. So while the choice is theirs, but the infrastructure now is available, and this had started April 2018, and by Q3 2018, it's almost a mandate that all CAs, certificate authorities in the world, are supposed to write to that ledger. So you can check out certificate transparency or .org if you're really interested in this subject. They've actually taken a lot of concern and care to explain the problems behind this. Yeah.
Should I ask the dreaded, should I ask, does anybody have questions or everyone is already scared about your security?
Yeah. I could have been lying about all of this, by the way. You never know. So.
Quick question for you on behalf of the audience here. You've asked for client certificates on the browser, right? Give me one use case where you would do this in a practical environment.
Yes. So imagine you are running an organization, a large one, right? And there are resources inside the organization that you don't want to put in a username and password to at every single time. Like, I'm an employee of my organization. There are resources that I should be entitled to. Currently, we put in username passwords, right? What we would do there in that case is seed the browser with a certificate that has been issued to that employee, and now you can access everything as behalf of that.
That is what all the MDMs do, right?
That is what?
The MDMs do, mobile device managers, AirWatch.
Yes, sort of, yes. So now
you're doing your own
yeah,
thing.
So now if I'm an SRE team, let's say, right? I have access to asset management, I have access to the compute infrastructure, the monitoring infrastructure, logging infrastructure. I don't have time to keep putting in a password every single time. So you see it in there. Also, so this is a representation of what regular client-server communication would do, which is what Kerberos is, right? So any two parties who have to validate the authenticity of each other.
Cool.
Actually,
we have a question.
Sorry,
where? Just raise your hand. Who's asking the question? All right.
Well, you got your chance in the last talk. It's your turn. I saw you raising your hand multiple times in the last talk. Go ahead, man. Ask
Sure,
it.
sure.
Yeah.
This is actually something similar to what Gautam asked, but what I wanted to know is client auth actually can be done using the SSL cert, but how do you go about the authorization part of it? Like, for example, somebody's cert is valid, but he's allowed a service A, but not service B.
Right. So now your example, it's the same thing when you take an API key. How do you define the scope of an API key? Authorization and authentication are two different problems. Once you have identified, is this person allowed to be here? The next step is, what is the scope of this? So scoping and permissioning is a separate model altogether which will be applied on top of this. Does it make sense? Like when you log into your Google Suite or something, you have limited permissions. You can still get in there, but what can you use is a different deal, right? Like I can get into this hotel, but I'm not allowed to be at RubyConf, but only GopherCon.
I thought when you said we are using client auth, so we actually identify its identity by validating his cert using our other CA. By using a CA, we verify whether this person's certificate is valid or not.
Right.
But who does this certificate belongs to, or
Now that's So if you go back to this part, your cert validator. So this function in here, you would do it that way. Remember, there's a cert in there, right? Mm-hmm. So this cert has a serial number. Now, if you go back to the cert, client cert over here. Let's just take this for example.
Sure.
Yeah, there's a serial number in here. Now, when this was issued, it was issued against a certain parameter set, right? That, hey, give me a cert. Now, when that request was made, there was certain information saved. Now, this is what we've done at CA Toolkit, by the way. Like, this is exactly the merit of this particular project that we have. So when you ask for a cert, you submit a post request and say that, hey, here's my email, here's my host address, etc., based on whether it's a server cert or a client cert. That information is saved in a database. So the next time you have to do a validation, you can pull that information back and apply it to a permission model. Does that make sense?
Definitely. Thanks.
Okay, cool.
All right, just before you ask the question, I know everyone's getting hungry. All right, so we'll take the last question.
Not a question, but explaining on how you handle multiple.
Thank you. Good.
Yeah, so there's roles you can define in the subject of a certificate where you can tell multiple operations or authentications, like what tasks or roles or you can do. So that you can specify in the subject and validate at the server side who is the client and what are the operations that we can allow for this particular client.
That would actually create a problem for the policies on the other side. So for every role or roles, you would also have to define the policies on the server side. But I completely hear you. There is authorization part, which is probably completely out of scope of the authentication part here.
I'll come back
But there
next
are
year.
solutions to this. We should talk.